In this video we're going to review some of the things we learned in Calculus 1 about Sage. So if you have the Calc 1 lab with me already, you should already be familiar with all of these things, and this is just a review. If you didn't have Calc 1 with me, you haven't used Sage before, then I strongly recommend you look at the Introduction to Sage. You'll find a folder in your course project for Calc 2 that says Calc 1 notes, and if you go in there you'll see all the lab notes from Calculus 1, and the first one is this Introduction to Sage, and you might want to look through there. You can watch the video if you want, or you can work through it on your own. Strongly recommend that as an introduction before you do this review. Okay, so first thing is just graphing. So to graph a function, use the plot command. So for example, I gave you this function, and first thing is to make sure you type in the function correctly. Remember that every multiplication has to be explicit in Sage, so when we type this 3x squared, we don't just put 3x squared, we have to put times there. Every time there's a multiplication, you must type that asterisk. And second thing, make sure we have plenty of parentheses. So in this fraction, we need parentheses around the denominator. That's because of order of operations. If you left these parentheses off here, then the plus 2 would happen after the divide. The plus 2 would be out here instead of underneath. So you have to have parentheses around there. Now for the numerator, we get parentheses already for the square root. Even if the square root were not there, we would still need these parentheses to get the order of operations right. Okay, and then to define something, you give it a name. In this case, the name is f of x, and you put a single equal sign. F of x is now defined to be this formula, and now we can plot it. So plot f, and here's the basic graph. Remember, by default, unless you specify otherwise, x-axis will start at -1 and stop at 1, and Sage will automatically adjust the y-axis to fit whatever thing you have plotted. Okay, you don't have to define the function first. You can just put in the formula right into the plot command. Now, most of the time we're doing more than one thing with this function, so it usually makes sense to define the function first, like we did up here, and then you can plot it, and then you can do other stuff with it later. Here's how you adjust the plot window, or a way anyway. This is the way I like you to adjust the plot window. It makes it explicit. This is the x min. That's the minimum on the x-axis, and the x max, and then y min and y max adjust the y-axis. Now this is true even if you're using different variables. So this function could be a function of time, and maybe you call the variable t. So maybe this is f of t. It doesn't matter if you're using t. X min, x max is the min and max on the horizontal axis. Y min, y max controls the vertical axis. Now if you leave these off, Sage will automatically choose it for you. Sometimes it chooses it well, sometimes it doesn't. So there are times when you might want to explicitly tell it what y min and y max should be. To graph more than one function, we just add plots together. So I'm going to add a plot of this sine of log x to the graph of f that I already have. So I define my new function g. And then here's the plot of f, same plot we had before, and I just literally add a plot of g. Now notice that my x min on g was different from my x min for f because the domain of this thing is x greater than 0, so I put x min as 0. If you left this x min at -10, you'd get the same graph, but Sage would give you a warning saying you tried to plot things that are not in the domain. Now here, both functions are graphed in blue, so it's kind of hard to tell which is which. So to distinguish between them, you can change the color, or you can change the line style. So color is great on the screen. If you want to print it out, then line style might be a better choice. So plot options, you just add on not add, but inside your plot command, you put a comma. So here's the parenthesis for the plot command, and all these things, this is the function to be graphed, and you put a comma, and the x's and y's, commas, 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 and then here's the color option, color equals red. Remember, the color name needs to have quotation marks around it. Sage knows lots of different colors. You can use salmon and fuchsia and teal and whatever you might like. It knows lots of different colors. Another comma, you want to put a line style, and again, quotation marks. It doesn't matter if it's single quote or double quote, but it needs to have quotation marks around the name of the style. There's dashed, and there's also dotted if you want dotted lines, and then there's dash dot, which combines the two. And if you leave off line style, then it's just solid as the default. And of course, blue is the default color. If you want to read more about graphing, go to the Calculus 1 lab about graphing and solving equations. There's a little bit about graphing in the Intro to Sage, and there's more about graphing in the Graphing and Solving Equations lab. Limits. So the command in Sage for limits is limit, and here's how you say x approaches something. There's not an arrow on your keyboard, so when you want x arrow 1 in Sage, it's x equals 1. So this is the limit of this function, which I just defined here, at, and then there's a comma, and then x equals 1 says x is approaching 1. Now in this, you got to make sure that x is a variable. Remember, Sage automatically gives you x for free as a variable. If you want to use any other letters, you need to declare those variables first, and by using the %var. If your x, if you up here you did something, you said x equals 10, this limit's not going to work. You need to declare x to be a variable again, so just be careful with that. Make sure you type in the function correctly as well. Here's a fraction, so I have addition or subtraction on top and on the bottom of the fraction, so I need parentheses around those so that the order of operations is correct. If you want one-sided limit, you add this dir option, direction. So dir equals right, or dir equals left, or a left or right side limit. You can also, instead of right or left, you can put plus or minus. The plus for this right-hand limit and the minus for this minus one, just like it shows up in our notation. You do need quotation marks around those, just like with the color and the line style. Okay, here's what I was talking about with another variable. So now I have a limit as t approaches -4. So x I get for free, but the t variable needs to be declared. So there's %var for variable, and then space and t. If you want to declare more than one variable at once, you can just put a comma here, and you can declare variable s and z and y, whatever you want. You can put them all there, and then just run that, and you'll have those variables available. Variable names can be most anything. There's a few restrictions, but you can name variables after yourself if you want. So here's the definition of this new function f that I'm taking the limit of. Taking the limit of f of t as t approaches -4. Now, of course, I didn't have to define the function f. I could have put this formula right inside the limit. That would have worked fine as well. If you want to know more about limits, go back to the Calculus 1 lab on limits, and there's more details. All right, derivatives. So there's a command in Sage called derivative, and it takes two arguments. A function you want to take the derivative of, which can be either a function name that you've previously defined, like I did here, or you could put this formula, this expression right here, could go right into the derivative. And then the derivative wants a second thing, that is the variable with respect to which you are taking the derivative. So after the function, you put a comma, and then x is the variable. There's many cases you can leave that off, and it will know what you mean, though it might give you a warning. I would suggest you get in the habit of being explicit about indicating which variable you're taking the derivative with respect to. Be careful if you have different variables. You get in the habit of putting comma x all the time. If you're using a function of t, make sure you put comma t there, whatever your variable is. Don't forget these explicit multiplications. 8 times x cubed, 2 times x. If you want the second derivative, same command. You just put a comma and then the order of the derivative you want. So you put a 2 there at the end. That's the second derivative. If you want 10th derivative, you put a 10 there. Remember the show command. This is the normal output from Sage, kind of computer speak looking. If you want it to look nicer, you can use the show command. You can put show right here on the derivative if you want. Type show and put parentheses around this. I've used the underscore. Remember, underscore refers to the last output. So the derivative command produces this output. Show underscore shows the last output, which was this, and so it makes it look nicer. Feel free to use underscore if you want. You don't have to. You can also copy and paste this output into the show command, and it would work too. Now those are the commands for computing the derivative function. If you want a specific value of the derivative, then I'm going to suggest you define a new function equal to the derivative, and then go ahead and plug in the values afterwards. It would be great if we could use f prime. Unfortunately, you can't type f prime in Sage. If you type f apostrophe, you'll get an error. That apostrophe is a reserved symbol. We've seen it a few times with the line style and the direction for the limits. There's apostrophes that are part of certain options and commands, so you can't call it f prime. I usually call it df for derivative of f. It doesn't matter what you call it as long as you know what your name is and use it afterwards. Okay, so I calculated the derivative of this function. Instead of just printing it out like I did up here, I've assigned that derivative to a new function which I called df for derivative of f. So to calculate f prime of 1, I defined f prime, so this is f prime, and then I plug in 1 afterwards. Okay. There is an alternative way to do this. If you want, you can go look at the Calc 1 lab about differentiation to see that, though that alternative method might be removed from a future version of Sage, and I think this is a better approach anyway. Once you have this df, you can calculate many values of the derivative as you want. If you want to do a tangent line, you'll have the derivative function available. You just plug in whatever number. If you want to do the second derivative at -1, calculate the second derivative just like we did above, but instead of printing it out, give it a name. I call it d2f for second derivative. You can call it whatever you want. And then use that new function you just defined, plug in the -1, and out comes the answer, 168. Integrals. So the command is integral, whether you're using an indefinite or a definite integral. It's the same command, it just has different information that you feed it. For an indefinite integral or antiderivative like this one, you're going to define the function. Don't forget those explicit multiplications, and then type the word integral, the function you want to integrate, and then the variable with respect to which you're integrating. So the dx here tells you the variable is x, and then f here is the integrand, that's the function we're integrating. Here's the answer. Again, you can use show if you want it to look nicer. If you want to do a definite integral, same command, but now this is a definite integral from -1 to 1. You just put those numbers here at the end. So the beginning is just like before, integral, function integrating, the variable, and then the lower limit of integration, -1, and then the upper limit. Okay, it always goes in that order, the bottom limit, and then the upper limit. If you get those backwards, then you'll get the sign wrong. Okay, if I reversed these, if I did 1 and then -1, I'd get +6/7 instead of -6/7. Remember, Sage can do derivatives and integrals where there's other variables involved other than just the variable of integration. In this case, I have minus capital A to capital A. Those are constants here, unspecified constants, but constants. So the answer is not going to be a number. It's going to be some expression involving capital A, but Sage can handle that. A, B, and C here are constants. They're unspecified, but they're just numbers. T is the variable. So all of these things I need to declare as variables in Sage. A, comma B, comma C, comma T, comma A, that declares all the variables. Then I can integrate, and I didn't bother defining this as a function first. I'm just going to put this expression right in there. And the variable is T. It's very important on this one you specify the variable because you could integrate with respect to A or B or C or T, any of them. Or for that matter, you could put X there, and of course, as far as X is concerned, this is just a constant. But anyway, and then minus A to A are the limits of integration, and here's the answer we get. We get an expression involving these various quantities. For more about integrals, you can refer to the Calculus 1 lab symbolic integration. And that's the basic commands of Sage that we'll need to do Calculus 2. Of course, as we do new things in Calculus 2, I'll introduce you to new things and you'll learn those as you go. So this review should be enough to get you started with our first Calc 2 lab next week.